Hello everybody, this time we are going to look at some basic animation loops in Unity. This will give a little bit of life to your scene through some movement. So what I think I'm going to do is take this magical levitating cube and give it a little more movement to make it feel like it's truly hovering. So the first thing we're going to do is we're going to create an animation folder. And then we're going to go to Window, Animation, and then Animation. And you can grab this and give it its own tab, kind of dock it here with all the project and console tabs. And so this is our animation window, and when we create an animation, it's going to have like a timeline here. So we're going to click our light cube object, and then it says to begin animating light cube, create an animation clip. So we click create, and it asks us where it should go. So we're going to stash it under animations and then light cube. Okay, so now we've got our timeline, and so you can add a property here as in terms of which property of the transform or whatever that you want to animate, but you can also hit the record button and then just make the change. So I'm going to leave the first keyframe where it sits right now. I'm going to jump forward in the timeline just arbitrarily because we'll change this speed based on how we think it looks, trial and error. And then I'm just going to move this object up a little bit, just enough to feel like it's hovering. And then I'm going to turn off the record. So we have a very simple, very fast animation right now. So the way I would like this to work is I want it to loop, so we need a keyframe where it comes back down to its initial point. And we'll do that by highlighting this keyframe and using Control-C. And then over here, I'm going to do Control-V, and then we can watch that animation and confirm that it's a little fast for me. And so then what I'm going to do is down here, sort of in the empty space of the timeline, if I hold Control and zoom out on my scroll wheel, I can get more timeline. It's a little bit of an awkward interface. If you're used to video editing, you would think you could just scroll, but there's actually nothing to scroll to until you put something there. So you have to zoom out this way. And I'm going to put our final frame way over here on 6. I'm going to put our middle frame over here on 3. And I feel like that's a much more hovery animation speed for me. The other thing that I'd like to do is I want this to rotate. So I'm going to go to our first keyframe, and well, I guess there's nothing really to change about our first keyframe, is there? We're going to leave that as our stay put. And then on the very last keyframe, I'm going to record, and on the rotation on the y-axis, I want this to have spun all the way around, right? So that's 360. But I'm actually going to have it be like just shy of 360, so 359.99, because when it loops, it's going to get back to 360. So then we can play that. And we've got a cube that hovers and rotates. Now, one thing you might notice about the rotation is that it kind of throttles down, pauses, and then speeds up, and then throttles down again. This kind of thing is all controlled by the curves of your animation. So down here, you've got two ways of looking at an animation. One is the dope sheet, and one is the curves. What curves does is it gives you a visual representation of how we ease in and out of these animations. For something that is meant to look like it takes place in real physics, usually a motion kind of starts off slow, ramps up to a constant speed, and then tapers off again. And that's what our up and down is doing, and it's working kind of well with the up and down. It feels like there's some kind of magical force, like bringing it up, slowing it down, bringing it back down again. But with the rotation, I want this to just spin at a constant speed. So at these anchor points, so you can zoom in on these and see that they are color-coded to refer to each of these properties. So this yellow one, that's our rotation on the Y. And I'm going to right-click on it. And you see this right tangent here. What this is referring to is like the kind of vector of motion to the right of this keyframe. I want to set this on linear. So we're drawing a hard line in terms of how the motion is ramping. So that is to say it's not really ramping, it's just going at a constant rate. And we're going to do the same thing on the other end, except we're going to do left tangent and make that linear. So now the rotational motion is a constant linear change, while the position is being ramped according to a curve. Not so easy to see the curve because it's such a subtle change in the value, but that green line is coming up to a small hill and coming back down in a curved manner rather than a straight line. Okay, cool. Now, as you see Unity freaking out back here, this should give us a little hint of the problem that we're about to encounter. Maybe some of you have caught it. I left it till now to have us discover. Just, I don't know why, for fun, teachable moment. But if you remember, back when we were setting up our lighting and our emissive materials, we had to make anything that was supposed to receive the lighting from our emissive material static as an object. We also had to make the emissive material static to have it cast that light. Well, I've just thrown a monkey wrench into that, right? Because I've made this object move now. And so if we try to run this at the moment, what's going to happen is that static is going to override our animation. So despite the fact that we put all that love and care into our animation, this cube doesn't do anything because it's marked static. So if you did all that to your cube and tested it and you were like, why didn't it work? That's why it didn't work. And I'm speaking from experience because I literally did this when I was testing it right before I fired up the screen recorder. So it's good to remember, like, oh yeah, I might have had an object set static. Maybe that's why I can't move it now or whatever. So we're going to uncheck static, which is going to lose us all of our nice emissive material, baked lighting kind of situation. So we're going to have to fake that with a light that can be moved. And so underneath the light cube object, I'm going to create a light, and it'll be a spotlight. No, it won't. It'll be a point light. And that point light is going to be childed under light cube, so it should literally be in the same exact place as light cube. It should also receive the animations that light cube is subject to, and we can give it a color. We were doing some kind of pink before, and so this is a real-time light. It can be a baked light or a mixed light, but if we are moving it, we do, I think, want it to be in real time. And then you can decide if it throws shadows or not. Shadows tend to create more realism, but they also are more taxing on the system that's going to play this back. So if you find your computer can't deal with generating real-time shadows from an animated light, then this is a good thing to turn off. So now we're going to test this. So you can see it's moving. You can see that our light is animated because we know our shadow is animating, right? You can sort of see here our shadow is getting bigger and smaller based on this thing going up and down. While Unity is baking the changes to our lights, these walls are looking a little screwy, but here the direct lighting is working very nicely. So these animations can be added to a lot of different properties. I've been doing the basics here with the aspects of transform, position, rotation, scale, but you can animate other aspects. And if we do the point light, you could actually change parameters of it. You know, maybe intensity would be a cool one to change. And so over time, we could have this light seem to sort of flicker or throb a little bit up and down by recording a change. And then copy pasting that change back and forth. Right? This thing again could be even more taxing on your system if we're changing real-time lighting effects in real time through an animation frame by frame. But I just wanted to demonstrate that it's possible to animate many aspects of objects that you put under here.